Brick, the most basic building material for any construction. With an estimated 190,000 brick kilns, producing about 250 billion bricks annually and employing 15 million workers, the Indian brick industry is the second largest in the world. However, there is a dark side. The brick manufacturing sector consumes about 35 million tons of coal annually, emits over 84 million tons of carbon dioxide a year, and consumes close to 500 million cubic meters of fertile agricultural topsoil as raw material for production.
Rapid urbanization in India has given rise to exponential demand in bricks, and these bricks are produced in small scale units, and these units are highly polluting, resource inefficient and unorganized. Looking at this, we decided to look at the interventions and we started acting upon it.
This is the story of how a steadfast vision and strong institutional backing combined to intervene and facilitate energy and resource efficiency improvements in the Indian brick industry. In the late 90s, the Ministry of Environment and Forests issued a notification banning all types of movable chimney kilns. Though this measure succeeded in reducing the pollution to some extent, it did not address the issue of use of agricultural soil as well as the larger issue of modernization of the sector. A significant change was required on this front. To drive this change, in November 2009, the then Ministry of Environment and Forests partnered with UNDP India with funding support from the Global Environment Facility to launch an ingenious intervention project, Energy Efficiency Improvements in the Indian Brick Industry. A detailed project implementation arrangement was drawn out. The project team started out by identifying 5 major geographical clusters that could serve as demonstration units. The key objective was to promote the production and use of a product that could be an alternative to the conventional solid clay bricks. Resource-efficient bricks, commonly known as REBs. REBs are products such as perforated bricks, hollow blocks that have perforations in the range of 20% to 50%. This would mean that these products use less of clay and fuel by that much percentage during the production stage.
For the volume of one brick, we are using only 40% or 50% of resource in terms of clay because it's a hollow.
In a solid brick, the heat has to go from only 2 sides. But when we go for a perforated brick, then we have different holes. So the heat can penetrate from those holes. So there is a reduction in the coal. Then the related GHG emission also reduces, which is the whole purpose of the project basically.
Produced mechanically using the advanced extrusion technology, the REBs have several advantages from an architectural point of view as well.
The finish, it is so very uniform, so very accurate, so very consistent. Steel and concrete requirement for a structure reduces largely because you reduce by 60% onto the dead loads of the building which are being designed.
The perforations in REBs help in trapping airspace within the holes, making them good thermal insulators. So, when these products are used as walling material, they help reduce the air conditioning load of the building.
There's benefits all round, from the point of view of design, from the point of view of environmental performance of buildings, from the point of view of economy, and from the point of view of even ease of construction.
With numerous benefits to its credit, the product now had to be introduced to the brick manufacturers in the selected clusters. This is where the local resource centers stepped in. The LRCs, being the direct point of contact to the kiln owners, are a key component of this project. The Punjab State Council for Science and Technology was one of the designated LRCs in charge of the northern region.
While interacting with the brick owners, we found they are not aware of this product and there was hardly any taker in the market also.
What followed was a vigorous awareness drive involving all the stakeholders from the producers to the end users.
UNDP प्रोग्राम के अंतर्गत 2-3 वर्कशॉप हम लोगों ने अपना वाराणसी में भी किया था, इलाहाबाद में भी किया था। मार्केट में अवेयरनेस का काम उन्होंने स्टार्ट किया था। उसी समय से हमें इस कार्यक्रम में मदद मिलना शुरू हो गई थी।
In fact, Terry was very good in pushing us to manufacture this Rabi bricks. It was something like making up the mind. I was prepared.
One of the stated outcomes of this project was enhancing public sector awareness about REBs. This was key to the sustainability of the product.
मेरे को डेमोन्स्ट्रेशन दिया ब्रिक्स का, परफोरेटेड ब्रिक्स और हॉलो ब्लॉक्स। आई वाज टोटली इम्प्रेस्ड कि ये तो बहुत बढ़िया आइटम है।
All the government departments, they follow BIS code. So when we studied in detail about the code, then we realized that the specifications that are given in the code, that is very difficult to meet. So we approached BIS to revise those specifications.
जैसे गवर्नमेंट आज की डेट में कोशिश कर रही है पंजाब के अंदर भी REBs को प्रमोट किया जाए, तो जैसे अगर गवर्नमेंट के ऑर्डर्स हमारे पास आते हैं तो हम कॉम्पिटिटिव रेट्स में अपनी प्रोडक्शन को बढ़ा लेंगे और हम पूरे कंपटीशन में माल देंगे मार्केट के अंदर।
Through frequent interactions with kiln owners and regular energy audits, the project representatives worked in tandem with kiln owners on increasing the efficiency of brick kilns and optimizing their operations. Slowly and steadily, the results started showing.
जैसे कि हमारे कस्टमर सेटिस्फाइड हैं और इसके अंदर मैं भी काफ़ी पूरा फुली सेटिस्फाइड हूँ और इस प्रोजेक्ट के अंदर, और आई एम वेरी हैप्पी।
इसलिए हर तरह से सभी के लिए, वो मैन्युफैक्चरर हों या कॉन्ट्रैक्टर हों या बिल्डर हों या एंड यूज़र हों, सभी को रिसोर्स एफिशिएंट ब्रिक्स के यूज़ करने से फ़ायदा मिलेगा।
Production of hollow bricks has increased by 150% between 2011 and 2016.
So definitely we see more number of units making these bricks as well as a larger market for these bricks. But again, this is only the beginning.
It is beyond doubt that the brick industry is vital to the nation's growth. This makes it even more important for the industry to be viable, competitive and efficient moving into the future.
Now we have a solution that is not only economically viable, resource efficient and also environmentally benign.